We've been working with the annuity formula in order to calculate the amount of money we will have in our account after a certain period of time based on certain deposits. But often we want to know instead, how much do we have to deposit in order to reach a goal or a target amount that we want to have invested or saved? So we can use the exact same formula, but if I'm looking for the amount that I want or need to deposit, then I need to solve that formula for the D. If you're going to be doing a lot of these, it makes sense to go ahead and rework this formula so that D is on one side by itself. In order to do that, I'm going to clear the denominator, clear the fractions here by multiplying both sides through by the denominator of R over K. And when I do that, then the denominator cancels. So now what we have is P sub n times R over K is simply equal to D times parenthesis 1 plus R over K raised to the nk minus 1. Now I'm solving for the D, and what I notice is that D is being multiplied times that big parenthesis, so to undo that we will divide by that exact amount. It's a little tedious writing it all, but we're going to do it. Whatever I do on one side, I do to the other side, so parenthesis 1 plus R over K raised to the nk minus 1. Okay, so putting this all together, I'm going to write out my nice formula here where D is all by itself, right? Because in this case, these guys canceled on the left and all we're left, on the right, so all we're left with is the D. I'm going to flip that around so that D is on the left, and it's equal to the P sub n times the R over K, and that's divided by parenthesis 1 plus R over K raised to the nk minus 1. Okay, let's use it. All right, here's a problem, and I wrote it out a little bit nicer this time. So here's a formula we just came up with, the D equals formula. So it is solved for the deposits, and then we just calculate what's on the right. It says, how much should you invest at the end of each quarter in order to have $150,000 in 20 years, given a rate of 5.5% compounded quarterly? Well, if you recall, quarterly means every quarter or 4 times per year. So our K is going to be 4. Our interest rate is 0.055 because I always move the decimal 2 places. And my N is 20 years. And of course, my P sub n, my future amount, is $150,000. So D is equal to $150,000 times the quantity, 0.055 divided by 4. All of that gets divided by this big parenthesis thing, parenthesis 1 plus 0.055 divided by 4, raised to the 20 times 4 minus 1. Okay, so we've had to look at how do you get this stuff in the calculator. So let's practice that again. 150,000 times my parenthesis 0.055 divided by 4, close the parenthesis, now divide by, and in the bottom I got to make sure I use the proper notation, so parenthesis again, 1 plus 0.055 divided by 4, close that, raised to, well, I can't put 20 times 4 if I don't use parentheses here, but 20 times 4 is easy to do in my head, so I'm just going to go ahead and turn that into 80, and then minus 1. Close the parentheses for the denominator, and boom, here's my answer. $1,040.75, right? That's what we would normally do because the number after the 5 is a 3. But this is how much I want to deposit in order to reach a goal of $150,000. If I round down, I'm actually going to be just a little bit short. Now, it might only be a few dollars, but still, I want to make sure I hit my target. So I'm actually going to round up, $1,040.76. So my recommendation is always round up to make sure that you hit that goal. All right, hopefully that made sense. Here's one for you to try. Go ahead, hit pause, and see if you can use the formula to answer this question. Assuming a rate of 6% compounded monthly, how much should you invest at the end of each month in order to have $500,000 in 25 years? All right, let's see how you did. So for this one, our P sub n, future amount, is 500,000. My rate is 6%, so 0.06, and it's monthly, so divided by 12. Then our denominator, parentheses, 1 plus the 0.06 divided by 12 again, but it's raised to the 25 times 12, n times k. And then we still have our minus 1. So let's try the calculator one more time here. 500,000 times, parentheses, 0.06 divided by 12, close that, divide, and now parentheses, don't forget, we got to have two of them there, 1 plus 0.06 divided by 12, close that, and raise to, now 25 times 12, I might not know that one off the top of my head, so that's okay. I'm just going to put a parenthesis here to start my exponent. 25 times 12 inside that parenthesis, close it. So now the calculator will do that first, comes up with 300, and know to use that as the exponent. And then we still have minus 1, and close the parenthesis on the bottom, hit equals, and I'm coming up with $721.51. This time normal rounding rules will work, right? We're going to be just slightly over our target at the end, but that's okay. Always want to at least meet your goal. Let me know if you have any questions.